be lost in the anode. Electrolytic cell that is run at 2 amps. For 965 seconds. And I put in there recall. There's 2 L's in recall. The atomic weight of copper is 63.54 grams. And use and 1 Faraday equals 9.65 times 10 to the 4th coulombs. Okay, and that's all the information. And also that we're talking about copper 2 plus 2 electrons going to copper. All of this is information that is provided. It is not being, there's nothing in there that is not needed. I needed to know how many electrons the process was.
Does it matter which way it was going? On this you have
well, yeah, it's going, I'm talking about the anode, which is going the other way. It's going to be losing, but I have to know it's a 2 electron process. And I use this value for for the Faraday, which is actually, it's technically it's 96,485 coulombs per mole, but I said 96,500 coulombs will be close enough for this particular problem to make the thing doable. So we're just, a minor approximation, okay? And now, so we start over on the left-hand side. What will we start with? Yeah. 965 seconds. And now I go from seconds to, well, no, to coulombs. And because I have 1 ampere is 1 coulomb per second. So there are 2 coulombs for every 1 second. We have that information given. And now I'm in coulombs. I want to go from coulombs to what? Moles of electron. So there is 1 mole of electrons for every 9.65 times 10 to the 4th coulombs. And now we might want, I'm going to go back and change this real fast into 9.65 times 10 squared to make this whole calculation easier. Okay? So now I'm in moles of electrons. Where do I need to go? Yeah. And there's 1 mole of copper for how many moles of electrons? Yeah. And that's why we needed this information. Okay? So now we're in moles of copper. What do I need to go from there? I'm going to go to grams, and that's why this information was provided. There is 63.54 grams of copper for every 1 mole of copper. And this particular problem, there'll be one like it on the test. And this setup is what it's all about. You do it in 1 string like this, and pretty much, if you botch the math, you get all the, you'll lose a point I'm grading the setup. So follow the setup. The logic should be clear. That logic is pretty easy to follow. Okay? So now let's do the math.
Oh,
Notice this 2 here
well, I did.
cancels out that 2 there. So we've got 1 there. Notice 9.65 divided by 9.65, that drops out nicely too. So all we have to deal with now is the exponents in that 63.54 business. So I'm going to have 10 to squared divided by 10 to the 4th. What do the rules of exponents have me do? That's 10 to the negative 2. So that means it's going to be equal to 63.54 times 10 to the negative 2 grams of copper. And now I can move that back 2, and that's equal to 0.6354 grams of copper. Okay, yes?
So we should study the units of amperes.
Yes, absolutely. 1 amp is equal to 1 coulomb for every 1 second. The other thing you need to know is that 1 volt is equal to 1 joule for every 1 coulomb. Those are the major things you need to know. Okay, those, without that, pretty much it doesn't work. But other than that, it's a pretty straightforward question. This is Faraday's law. Okay, so is that a wrap? Okay, let's stop it and start it again quickly. See